And
Yeah,
I think
Kyler, I know you love that.
no, I don't love it. I just do it out of necessity or perceived necessity. Um, I don't use custom messages though. I usually throw float 32 around. Um, but I would much rather anything I can visualize in RViz. I want to do that. Um, By the
So
way, there's no way to visualize an arc in RViz. You have to write your own damn arc. Just
could
my
you not
rant
do
for
a
the day.
really thin n-sided polygon?
No, I don't think you can do an open poly. Well, so you end up having to do lines. You build it yourself.
Oh, okay.
You can't do something. Um, I would have even gone for a circle, but you can't do a circle without the center filled. You can do it. You can make the cylinder one high, but you can't do just the outline of it. So that was,
Does this sound like a ROS2 feature request?
it sounds like something I just have to get off my butt and write for my purposes.
So what are the custom things you end up writing? I know you have your own custom navigation, path planner for read
Yeah,
ship.
and you presented something. What? Oh, it's been a few weeks since I've been able to join. You presented the new nav stack, was it?
Are you referring to the behavior tree?
Yes. Yes.
Yes.
And I haven't gotten back to that, but I was encouraged by that maybe that is a solution.
Yeah, I really like it because, um, you can define everything using XML, and it's very easy to have nested states that way. I really like it, and I've been trying to push for it at work now because I really like it that much.
I am going to circle back to it. I'm trying to get a few other things lined up first.
Sure, and I've been putting this off, but I'm supposed to have a demo where you define your waypoints using an XML, and the robot executes, in a dumb manner, but it executes those waypoints so people can visualize the state transitions and how powerful it can be.
I don't want to monopolize the conversation, but that sounds good. Did I ask before, can you lengthen the path on the fly? So can you
Not
continue to
yet.
add more waypoints?
Not yet.
Okay.
But I hear you, Kyler. I hear you that, I think we talked about this a few weeks ago, but
Okay.
I know that.
Sorry.
No. I just want to make sure you're heard. I know that is doing dumb waypoints like that is not ideal.
Oh, yes, there was that. Yeah, and I'm developing some new solutions too, so maybe I'll circle back and see what fits.
Sure.
We have any updates on projects? I see Juan online tonight.
Hi, Matt. How are you?
Doing well. Yourself?
I'm trying to catch up with the tractor. I didn't work in it for the last 6 weeks. It wasn't. I'm having some problems with other things, but well, I think that I will catch up. The good things is that I managed to buy a Tensi and a Citron board here in Argentina. So I have the replaces for the pieces if I broke something, but I'm having problems with the last things that I was working. I was having problems with the electric installations and having some shortcuts, but I didn't work it. So I'm a bit stuck.
So you're going back through the wiring in the circuits?
Yes, yes. And I will try to rebuild the board that you built, but I'm not sure, and I don't want to touch or break something without being sure about it. So I need to pick up to work in the electricity part of the tractor.
Okay.
But mainly I'm stuck with a lot of problems, and that was why I didn't work in the tractor.
Maybe having a good schematic of how all the little electronic boards come together, make it easier.
Yes, but I didn't do the work of reviewing the documentation that I'll leave and you leave in the Google Drive. So I'm not sure if I think the documentation is there. Maybe there is a need to put it more. I don't know how to say declutter the documentation, but the documentation is there. So maybe we need to put it more pretty, the documentation, but documentation is there. There isn't something that I don't know. The community is very supportive. So if I have some a problem or something that I don't understand, I can always ask in the Slack. But that wasn't the problem. I'm a bit disorganized, and I need to to get tidy with all the things that I have pending, and this is one of the things that I have pending.
Okay. That's good. That's a good thing to do. I'm going through the circuit again on the lawn tractor, so it's a part of it, sort of like a iterative approach. You'll go through it a few times.
Yes, but mainly is to try to participate in the community again because it's always something that I will learn from listening to the other guys' problems, and maybe I can skip one of the future problems that I will have. So, but I wasn't able to do it. I hope that now I can begin working again with this.
Awesome.
I, I don't understand. I come to the end of the reunion or the beginning?
Beginning.
Ah, okay. I'm not sure about the time zones.
Yep. It'll switch again in October.
Okay.
Jeremy, do you have any updates on what's going on out there? Ross 2 or other?
I don't have any updates. I'm just hanging out, listening what others are saying.
I don't have a Ross 2 robot yet, but been looking at it for the navigation stack to do a demo, a GPS
Oh yeah,
demo.
cool. Yeah, I thought that. Gosh, I forget his name now. trying to think, but I thought that that guy was, what is his name? You and I talked to him.
Joe?
No, not Joe.
Steve, the
Steve
guy who,
McKenzie. Yeah,
yes,
yeah. Did he talk to you guys?
I've been to the navigation meeting a couple times, and
Yeah.
I've been on watching their GPS demo. So kind of one of the idea was to get a robot together and then test the navigation 2 stack with outdoor robot.
Oh yeah, yeah. I talked to him, and he said he was going to reach out to you and try to entertain presenting on this call, but I don't know if you two got together, and I'd missed several meetings since the last time I talked to him about that.
That'd be a great idea. Have them give us an update where we stand, what we can do.
I suggested that, I mean, there on that working group, there's a lot of people. So I suggested there might be somebody else to present, but at first he declined, and then he came back like a week later and said, yeah, I think I should do that. And, but I didn't know if he actually talked to you. I haven't talked to him since then.
We don't have a scheduled time yet, but I can follow up. That's a good idea.
Yeah, he's a great resource. I would touch base and see if he can present.
Jeff, do you make any progress this weekend?
sorry, was that to me?
That's Jeff.
Oh, Jeff.
Well, I've been thinking about, yeah, I keep using the excuse I need to fix my steering. And I keep thinking, well, in order to fix the steering, I got to go through the whole thing and get it all figured out. And because what I need to do is get the whole thing fixed and running, and then I need to measure what my steering, if I drive in a circle, how big a circle does that give me? And I remembered I did this a long time ago. So if I look at, let's see, how do you do this? Start sharing screen 2. So a long time ago, I ran this as a result of where I drove in a circle. I was thinking it turns tighter if I turn right as opposed to left, but at the top here it says hard left. And the numbers here, so if I go from the top here, 14.6 and down to the bottom at 13.1, that says this diameter of the circle is 1.5 meters. And that's all I really needed to know. So that took away my excuse for not doing anything. So I know that now. So I went and looked, and so if I look on this page, which is, let's see, can I get my links back now? I don't know how to post while I'm doing this, so I'll post this in a moment. So anyway, here's a page on the Ross Wiki saying here's how you convert between rotational velocity and steering angle. This is out of the TEB planner stuff. And I was trying to figure out, how do I figure all this rotational velocity and stuff? But they give me this diagram that says, here's the, if you're driving around this point here, these ICR is what? Instantaneous, instant center of rotation, they're called. So that's the center of your circle right there. And the R is the radius from the center of your circle out to your base link, and then to your front wheel. And they're showing it to one front wheel as opposed to the center. But they're saying if you want to calculate the steering angle of one wheel, and I'm not sure if that's what I want to know, but that's close enough. Down here it says you can calculate phi is arctangent of wheelbase divided by R. So wheelbase on my vehicle is half a meter, so it's 0.5 meters from there to there, and the radius happens to be from that from this one, the radius half 1.75 meters. So if I come back here, so if I take the wheelbase of 0.5 meters divided by a radius of 0.75 meters, gives me 0.66 like it says, dimensionless, 0.66. So you take the arctangent of that, and it gives me 3.7 degrees or 0.588 radians. So I come back and look at this. That's telling me my angle here. When I'm cranked the full hard stop and drive in a circle, that's 33.7 degrees is what that's at. And I was just trying to say, you know, is that close to even what it should be? And it looks like that is. So it turns out to be a lot simpler than I was trying to make it. I was trying to figure out, I got to get rotational velocity and curvature and all this other stuff thrown in there. So basically what I was trying to do, I just wanted to say, if I send a steering angle, let's say 30 degrees from Ross, how do I convert that into a number to send my RC servo to set the actual steering angle? So now I've taken away all my excuses to actually do something here. And the other thing that came out of it was originally this whole page here on Ross is telling you how to convert rotational velocity that the normal path planner puts out. How do you convert that into a steering angle for an Ackerman vehicle? And it turns out that if I take that and say I want to turn it say 0.5 radians per second and run it through these equations, it's going to say, okay, that should be say 30 degrees steering angle. And if I go back to my odometry here, I think of all these fields I've got here. I've got, I don't know, I've got like 20 different fields I'm plotting out. One of those is probably rotational velocity that I've recovered from my odometry. So theoretically, as I'm driving this, which tells me I have a 1.5 meter diameter circle, that should also tell me that my rotational velocity is X number. And I have to go through. Of course, I didn't put any headings on this, so I have no idea what these fields are. So I have to figure out what those are, or actually go through and make it actually run. This one here says minus 0.5807. That's probably my rotational velocity right there. So I think the 1.6 something is my forward velocity, and minus 0.52 is probably rotational velocity. Here, let me see if I can waste everybody's time here by trying to plot this line. And now here I was complaining that it always put this thing halfway across the screen. Well, it didn't this time. It's actually showing it where it's supposed to be. So this value right here may or may not be, oh, come on. This may or may not be my rotational velocity. So I don't know. And looking at everything, I have no idea if this is correct or not. So, but anyway, I should be able to compare, you know, if I say turn at 0.5 radians per second and then go back and look at my odometry, which is telling me how fast I'm actually turning. So that may or may not be something to validate against.
It's definitely something to validate against. Yeah, just make sure you divide your rotational velocity by your forward velocity.
Okay, is that the definition of, is that like curvature maybe? Because I was thinking also that, you know, all the stuff should relate. I should be able to get curvature and rotational velocity and steering angle and forward velocity, and all of it should be interchangeable. I should be able to pull stuff in and out and verify that it all works. And if I get to that point where it all looks like it's verifying, then I might actually know how it works for a change. So, and I'm guessing this is not rotational velocity because it starts out at minus 0.5. So that's not what this plot is. That's the wrong plot, I guess. So, but anyway,
look for something that looks like noise at v equals 0. At 0 velocity, it should look like tiny little noise.
Yeah, that makes sense. Or if I go back and look at my code where it's putting out, because I had some code that's putting this stuff out. This isn't an actual odometry message, but I was just putting out a message saying odom W, so that's my wheel odometry. So if I go look at it by print statement, I should be able to figure out which one of these, which field is which. So.
Wait, this really is, I can't see, this is on my phone. You have an ODOM message?
This was not technically an ODOM message, but it's all the values I used to create an ODOM message. So theoretically, yes, we could equate those together. And here's a bunch of fields that say 0 to start with. So it could be any one of these. But so the point is, with old data from a year ago, I should be able to I got close enough to say, okay, at full left, that's like 33.7 degrees or 0.588 radians. So that takes away my excuses. So now I have to go actually set this thing up and drive it around. And once I drive it, then I can say, create an actual odometry message, and I'll have the real rotational velocity come out in real time. So I can verify against that. So anyway, that's what I've been doing. I just thought about that today, that I could do that. I had to pull this up off a backup hard drive, because once I left Danfoss, I backed up all my files, and they're on different hard drives. So I had to go recover this stuff, and all the other stuff I want is buried on that drive somewhere. But so one of these days I should recreate everything, and I'll have all my stuff again. So that's kind of where I'm at right now. I just need to go figure all that crap out.
Hey, Jeff, what are your sources of odometry? I guess one's like a wheel sensor, a physical wheel sensor. Are you also using
For my
GPS?
wheel odometry, I have an encoder on both back wheels, which gives me, just like if you had a differential drive robot, it gives me, I can recover forward velocity, forward distance, and the heading, my current heading that I'm driving. And this when I plot the circle that was plotting, that's the heading. No, actually, that's my XY position. And theoretically, here, let me go back and share this again. Share screen, go to this one. So up here, this one says heading. So as I drive around, as I'm driving in a circle, you can see my heading's changing. It goes up to 360 and then bounces back down. So as I go around, that's giving me the heading. And here's the velocity while I'm driving. So right here, while I'm driving at a constant speed, then you can see it driving in a circle, my heading goes from 0 to 360 or 0 to 6.28 if you're looking in radians. So it gives you all the standard stuff in odometry message would give you. So this is my wheel odometry. At one point I did this by plotting my GPS data, which should give me the same XY location, and it should give me the heading data. You know, that again, I can compare those back and forth. Those should match. And let's see what else I have. If I had an IMU on there, that would give me essentially my heading data I could get from the IMU, but I don't have one on there right now that I can fire up and look at the data.
So all this data, just so I understand, is from the physical back wheel encoders, and that's it.
Yes, it is.
Oh, okay, that's pretty cool.
One of these fields might be the requested speed or something, but essentially, yeah, all this data is from the back wheel encoders.
Okay, and then so when you were talking about validation, you're talking about comparing it to your GPS XY.
Basically, in general, any sensor you've got on your vehicle, say any sensor puts out heading, I should be able to compare all those together, and all the headings should match. And if I get anything that gives me distance, I should compare all those and be able to get that to come out. And like right now, I'm trying to translate from a ROS request that says, I want you to turn at this steering angle, or alternatively, I can get, it says, here's your rotational velocity I'm requesting. So you have to convert that to steering angle. But, you know, just going through the whole process, all that stuff should eventually come out and match. You should be able to take any given number and convert it to anything else and have that come out. So that's kind of what I've just been thinking about. I'd like to say that's what I've been working on for the last 3 or 4 months, but basically I haven't done anything for the last 3 or 4 months. So I need to get back and start working on the stuff again.
Thanks.
On that TEB local planner, there's a field to select sending out angle instead of rotational velocity. But
There is, and that one page I had pulled up, this one is, it's an extra little utility that's with the TEB planner that they say, oh, if you want to convert rotational velocity to steering angle, you can fire up this node and it will do that for you. And it basically takes your wheelbase, your front to back distance on your vehicle, and you feed in the rotational velocity and says, oh, that really should be 33.7 degrees to turn at that speed. So they give you a little thing that converts at least one direction, and just by flipping things around, you could probably get it to convert the other direction too. So it would actually be nice if you can come up with just a standard way. Since Ross always liked to put out the standard navigation software, likes to put out forward speed and rotational velocity, but on an Ackerman vehicle where you have to actually set the angle, then you can use this routine to do that. And as Matt says, there's just a flag in TEB planner. You can say supply steering angle as opposed to rotational velocity. So you can just flip one bit to do that. And it's nice to be able to have like this function, this little node that converts back and forth. So that way you could say take any planner, and if it's putting out rotational velocity, this will then convert to a steering angle. And in reality, it's just a matter of scale factor. If it says, here's a rotational velocity of this. If you apply the right scale factor to it, you can pretend that it's steering angle, and you can go ahead and use that. So that's another way around it. But I was trying to figure out. I need to figure out how this actually works, so I can say yes, I understand it, and be able to put in the value and understand what it's doing. So that's kind of where I'm at, just trying to figure that out.
If you map your steering to curvature, you never have to even think about steering angle.
Okay, that's the other thing is I got to figure out what curvature is. And it's something about one over radius, and somewhere it says
1 over radius.
meters,
Yep.
but somebody says in Ross it's 1 over 1 kilometer, or so there's
Oh.
more little details like that I eventually did figure out and make all this stuff match.
Basically, you can always say, I just want this rate of turn, and I know my velocity, which is what CMD-val gives you. And then you just say, oh, here's the steering setting. Done.
Okay, well, when I get to that point, I'll let you know if that made sense to me or not.
All right.
So that's all I got for the moment.
Okay. Thanks, Jeff. So on that curvature, Kyler, you just take your command velocity and then you divide your current velocity by the
Yeah. Well, be careful. This is a good place to screw up, meaning I've done it. Turn command vel into curvature first using the requested velocity, which may or may not be your current vehicle velocity, and then use your actual vehicle velocity to figure out what rate of turn or whatever you want. Does that make sense?
So the command velocity is giving you rotational velocity. You divide that by your requested or ideal, and that gives you curvature.
And that gives you, yeah. No, that gives you rate of turn, yeah, which is equivalent.
So
Or, I'm sorry.
is that like a
Yes. Yeah, if you, yes, I need to write that down, but yes, I think you're right.
So you're doing requested velocity over ideal velocity? I lost that.
Yeah, so the thing, if you don't use the requested velocity with the requested rate of turn, there's going to be a mismatch. So the requested velocity or the requested rate of turn over the requested velocity, you get the curvature, the requested curvature from that. Then if you apply your current velocity to that curvature, you'll get the necessary rate of turn to match the requested curvature. Was that confusing enough?
That makes sense. That makes sense.
Vinny needs to pull up the whiteboard and draw this out.
Yeah, I totally support that.
I'll do it.
I got one of these little static LCD screens for writing on. Yeah.
No, I guess it should be requested, right? This is Omega, right? Omega requested.
Oh God. I'm gonna use Greek letters on.
Over. Well, I mean, I guess what's rate of turn? Is that like a rotational acceleration?
Rotational velocity. So it would be radians per second.
Is it?
So is it radians over radians per second? This might be a waste of time.
I think it's really important, and I would love to.
Okay.
I always sit down and I figure it out from scratch every time I do it. So I am happy to work through it.
Okay, let's do
so
it.
you're requesting, let's see, you're looking at, it's the, so the rotational velocity would be radians per second over, oh, and Jeff just said it. And then it's over your forward velocity, which would be meters per second.
Oh,
And
okay.
that'll give you what, radians per meter, and because of the magic of radians, that pops out as curvature, or a radius, or is that the radius? And then you flip it over to do curvature. I always have to draw it out. Sorry.
Right? And then you're saying multiplied by yeah. Is that what you're saying? If you can read my handwriting.
So we do angular z divided by linear x, and that gives us curvature. And then how do you convert curvature to steer angle?
You don't. I mean, one way to do it is don't do it. Use an IMU. Or if you mapped your steering to curvature instead of steering angle, because steering angle is kind of meaningless. You have to know you have to put your wheelbase in there and all that stuff. So if you just throw out steering angle, forget about it, and just do curvature, you should be able to map your steering so that you know the curvature wherever your steering is set. Does that make sense?
So do you empirically measure your curvature? I mean, do you take it out and drive circles and then map that
Oh, no.
to the
I have an
angle
IMU.
position?
Yeah, you should be able to map the entire steering pretty darn quickly if you have an IMU. Just run it through the whole range and drive forward. Does that make sense? So, so if you're getting a value of your steering is at 0.7 of its travel, and your rate of turn is some value, you divide that. Let's see, you divide that by your forward velocity at that moment, and you've got your curvature, and that's the number you want.
So like lock to lock is -1 to +1?
Yeah. Yeah. Yes. That's what I typically do. But I'm thinking you probably want to, if you're making a map of your steering, you're probably going to get back some analog value, right? And so you just map that.
Wait, Matt, why did you say your curvature was -1 to 1?
I was wondering about this kind of like steering. So if you move your wheels full to the left, that'll be -1. And then if you move your wheels full to the right, that will be +1. It's just like
Careful.
lock to lock.
It left is positive, right?
Okay. Yep.
Right hand rule.
I'm trying to be Ross-like.
That's good. It's important. So we have -1 or a +1 to -1, and then you divide your current steer angle percent or steer
value.
range?
So
Steer
yeah,
value. Yeah.
you're just getting some number from a potentiometer or something, pulse sensor.
Divided by your velocity, your forward velocity, current forward velocity.
Yeah, I've got to write this down. This is where it gets fuzzy.
So if we were going, if we were at 0.7 of our steer range and we're going 2 meters per second, we just be 0.7 divided by 2.
Wait, 0.7 of your steer range.
Divided by a forward velocity of 2 meters per second, just as an example.
Right. But like, I'm still a little confused what that value is. What does this mean? What I wrote in red.
Okay. Which part? The 0.7 part?
Yeah.
Yes.
So the 0.7 is just an arbitrary mapping of how far your wheels can turn left and right. And whatever that range is, you're just calling that plus and minus 1.
Oh, so that's the thing that I think you want to map. So I think you want a map that says, oh, a value of 0.7 here is equivalent to a curvature of whatever. And you really want the reverse mapping then. So you take the 0.7 and then you say 0.7 equals your rate of turn divided by your current velocity. Or 0.7, excuse me, maps to your rate of turn divided by your velocity. And so
Okay, so go ahead.
So yeah, so the easy thing is if magically somehow 0.5 equates to a 0 rate of turn, you know that's the middle. That's the 0 curvature. So infinite radius. So that's the place to always start when I'm doing this. I check my math that way. Go ahead, Vinny.
So yeah, so essentially what you're doing is you are creating an empirical relation between your curvature and whatever your analog sensor is giving you.
Yes.
Okay. And then you can solve for, if you know your requested forward velocity. So yeah. If you know your requested forward velocity, then using this mapping between curvature and your steer sensor, you can get what you should tell your requested rotational velocity for.
Oh no.
No? Okay.
I think I understand what you just said, but so given this, now let's say we have this map that I'm describing. Now you get a CMD-vel message, and it says, turn at this rate and go forward at this speed. So all you have to do now is take that rate of turn divided by the commanded velocity, forward velocity, and you're going to get back a curvature. And then you just plug the curvature into this map, and you know the sensor setting that is your target.
Okay. So basically what we're describing here is how do you get from a command velocity to a steering angle. And so you'll run your control loop on the sensor value because now you know the mapping. Okay, I understand. Is there anything I can do on the whiteboard to make it understandable for those in the future?
How do you build that curvature map from -1 to +1?
So, yeah. So it's basically the same as you would do for steering angle. You just, so how would I do it? I would, you don't necessarily get from -1 to +1. You get from whatever lock left to lock right is, or lock right to lock left. So if you just start it at one lock and get up to some speed, some reasonable speed, and then move to the other lock slowly. So just sweep the steering while you're moving forward. That's it, basically. You'll have it. Average some numbers, and it's going to be noisy. But if you do it at a fast enough speed, you're dividing by velocity, so the noise goes down and you'll get a signal out of it. If you do it really slowly, it will be ugly. Is the silence disbelief, or is there something I can explain?
I was trying to figure out, if you go like 2 meters per second and then 4 meters per second and went lock to lock, do you get the same mapping?
Absolutely, yes. So it's going to be different noise. There's going to be noise in it. But yes, you should get the exact same mapping, no matter what speed you go, as long as you don't introduce slip, etc. So yeah, curvature should be independent of speed, and it's essentially it's just curvature is equivalent to steering angle, except we don't have to do the funky operation of figuring out the wheelbase and all that stuff as a midway step.
So you'd have to use something like, you'd have to use a sensor to detect your forward velocity, and then you'd have to have another sensor to measure your current rotational velocity, and then you have a sensor to detect your current wheel position.
Steering angle, yes, exactly.
And if you have those 3 measurements, then you can map curvature to your steer angle.
Yep. And it should take all of 10 seconds. Well, depending on how fast you want to turn or sweep.
So what I'm planning to do is take my vehicle, which has an RC servo for the steering. I'm going to, at say full left, I'm going to get a value like 2,000, and full right, I'm going to get a value like 56,000 or something. And I'm going to use a map command to say convert that to either plus or minus 1 or plus or minus 100%. And then that'll take care of the linear mapping of my vehicle. And then I have to figure out how do I convert a requested angle to say plus and minus 100%. And I hadn't planned on putting curvature in there anyway, but that's something I can look at.
And I wouldn't even, you don't even need that intermediate mapping. You can map directly to your, whatever your PWM command is, your duty cycle. So just sweep through the duty cycles, collect your data, that's your map, and then just do a binomial fit or do a Gaussian whatever, and you'll be able to stuff in a curvature, and the duty cycle will pop back out.
Okay. So when all is said and done, no, I don't understand this, but I put a note in the comments that hopefully I can go back on YouTube and say search for curvature under Ross Agriculture and go over this several more times when I get that far. So that's one problem I see with putting this stuff on YouTube. You have no, there's like 500 videos out there and you have no idea what's in any of them. So I try to put a note to myself, a breadcrumb to say, here's where I can go to refresh myself on this.
I promise this is really easy. No hard math involved because I do it.
I guess, Kyler, you said you're on your phone. You can't view the
Yeah, I can
the whiteboard.
see it, kind of. It's just kind of small.
Sure. Okay.
I
I
turned it
guess
over. Now
for
it's,
those-
I can
Okay.
see.
I was just gonna ask: did I accurately capture what we're talking about in this whiteboarding?
I can't say at a glance.
Okay. But, well,
I-
let's hope I did.
I feel like I
Then-
should go pull out my cart and do a demo real quickly. Yeah, I need to map that too. So
On the part how to develop mapping under number 1, you said get your W current is that we get that from the IMU, and the V current we get that from either like wheel speed or GPS.
yes, forward
And then
velocity.
Steer angle we get from your steer sensor.
Oh, I do notice sweep lock to lock at a given forward velocity. I'm going to harp on this. Just make sure that you are always dividing on your real or by your real forward velocity, not whatever you specified, because if there's a difference there, that'll be important. You want to do all your actual values.
Did I make that
Yeah,
clearer?
and it wasn't that it was you weren't saying it. I just want to harp on that.
Sure.
And there's probably a really good method to collect this. If you do it really slowly, you're going to have a bunch of values for every steering angle. And then, yeah, so it's basically a matter of some kind of a function fitting. I found a Python. There was a function for that. I forget the name of it offhand, but I'm sure someone else will know it.
And then to fit that, you said like you use like binomial.
Yeah, I had a while ago. I found some Python. I haven't used it in a while. It was something that I could throw, throw a bunch of points, and it would spit back an equation.
Are you referring to
Polynomial.
scikit?
That doesn't sound
Scikit has
familiar.
like a polyfit.
Yeah, polyfit. Yep.
Yeah, it either belongs to
yeah.
scikit or numpy.
It is. NumPy. It is. Yeah, I think I use NumPy. NumPy.
NumPy, yeah, numpy, yeah.
Polyfit. Yep, that's it.
And whoever's creating the whiteboard, keep in mind that stuff's scrolling off the bottom of the screen, and I can't Can't view it.
Oh,
I do.
Before you're done, just scroll it up so we can see the bottom, and that way somebody will see what's down there.
I do recall that Polly. Oh, go ahead. Sorry, Vinny.
oh no, all I'm saying is my whiteboard stops at this yellow marker right here.
Okay. I can see something down below that, but that's okay.
Oh,
My recollection is that PolyFit can get pretty crazy trying to perfectly fit the numbers. There's got to be something better for, and I can't remember what it is, but it's.
isn't this just a linear regression at this point?
Yeah. Yes. Yes. Absolutely. So use more appropriate tools.
And from my point of view, I don't plan to run it back and forth and map it. I'm just going to use Matt's concept where you say from center to left, it's this scale value, and from center to right, it's this scale value. So you're basically setting the slope from left, the slope on left and the slope on right, and not have to go through and create a map of it actually moving and try to analyze data back out of that. So
it is. I suspect that it will not be strictly linear, but it might be close enough for your purposes.
I think for what I'm doing, it should be close enough.
Oh no.
But just by definition, the Ackermann steering is not linear, but I think if you just correct for the fact that you got to slope one direction, slope their direction, it should come out close enough to be usable. In fact, I think on the tractor that we did at Danfoss, that's what we ended up doing. We basically did the same. I didn't realize at the time, but by using these cute little programmable blocks, we're doing exactly the same thing that Matt was doing with his the stuff he put in his Arduino code. And it seemed to work out good enough. And before I forget, since I'm putting markers into the comments, Kyler, what's the brand of that little tractor you have, the one that you did the steering demo on one time?
The steering demo a long time ago, just the quickie demo. That's a Yanmar, the little red one.
Yanmar, okay. That's something else. I go to search for it and I can never remember what the brand of that was. So now I'm going to put a marker in that for that too. So
it's a Yanmar YT359.
Okay. I kept thinking of Kubota, and of course, when I searched for that, it didn't show up because that's not what you have. So, but now I'll have it.
Yeah, was there anything interesting in that video? I was actually using a servo back then.
Yeah, you had an RC servo connected to your hydraulic valve. When I tell people, oh, you can do it like Kyler did, and then I can't ever remember what the link is. So I have to go search through all the back stuff for the on Slack to find it, and stuff keeps falling off the back end of that, so it's hard to find there too. At one point, Doug wanted to do that. He wanted to take one of the giant servos and run his hydraulics. So I was trying to point him to that, and I couldn't find it. So I think I finally did eventually find it. I showed him where it was, but again, just the thing, once you put it on YouTube, you lose track of what's in these things. So.
Yep. Yeah, I did a lot of work with hydraulics on that, and now I kind of miss that original method that I did. It's tempting to go back and try to refine that and use the valves that came on it.
Did you ever find a tractor junkyard where you can go and buy used linear valves to make the stuff work?
Oh, there definitely are tractor junkyards, and I got some Deere valves for cheap that are usually really expensive. I did find a guy who was selling a lot of weird surplus valves and had plenty of proportional valves. They weren't dirt cheap, but they were a lot less expensive than some places. I ended up buying new because it was easier. I've been buying DO3 valves. So you get a DO3 manifold and then screw the valves onto it. So they're pretty standard, and you can get proportional, what I call closed center. You can get proportional fairly reasonable, so it's a few $100s. Vinny, if you're not going to do it, I'm gonna narrate.
Oh, I think I was on mute. Basically, you're getting command velocity, right? And
Yes.
we want to use this omega over v times this alpha to get the sensor value, and then you want to control. That's how I'm going to signify control. You're going to control on this, and this could be done on your microcontroller, right? This is basically what your
Yes.
driver should be doing. But in terms of raw space, we're here. But I feel like your driver should be getting this command velocity and then doing this quick multiplication and controlling that way.
So if you do it that way, you're going to have to make sure that your microcontroller is not only getting your sensor input, but also your current velocity, which may or may not be convenient. Wait a minute. I said that. That's only if you're using IMU, which is what I do. You do not need your current velocity in the system that you just described. That was misleading. My bad.
Yeah, because this is omega requested.
Right. Over omega, okay. Yeah. Velocity requested. Right. Without if you're not using an IMU, then yes, it is simple.
Cool. So now we should have two whiteboards that kind of explain steering.
And if it doesn't work, you can come and blame me. Yeah.
Oh, we will. We'll show up at your front door and we'll say, damn it, this doesn't work.
Cool. We'll have a fix-it day.
Of course, it'll be real hard to drive our tractor over there if our steering doesn't work.
I'll strongly encourage the use of the IMU once more. I'll tell you that these things, if you're using a sensor like this, don't just map it once and be done with it, because they get hit, they get jostled. Things can happen to them, and I've had clamps that kind of work their way around. They don't always give the same values, and then you'll get this weird behavior where you say, hey, drive straight, and it doesn't quite drive straight, and then the errors pile up in your PID maybe, or you just get off the track far enough that it turns into a correction and it gets back, but you'll know it's happening, and it'll be an undesirable behavior.
just a story from the trenches. We had an IMU on our tractor at Danfoss that had a built-in magnetometer, and it worked just fine. We could go out and drive it around, and one day they went out to run it and it wouldn't work. And it turns out somebody had taken a big chunk of steel and laid it on the floor right in front of the seat, and the IMU was bolted to the seat. So
Yep.
it didn't work anymore because somebody had just stored something there. So, things like that happen too. So you don't have to bump it. If you just somebody lays something there they shouldn't, that can be a problem.
That is why I cheat and use dual antennas usually, because I just turn off the magnetics. Yeah, magnetics around the tractors just bother me.
Great discussion. Very interesting. Thanks, Kyler. That's tuning a vehicle is always a little bit tricky and lots of different ways to do it. Is there anything else for tonight's meeting? All right. Great seeing everyone. Thanks for taking notes, Minnie. This will be very helpful if we can ever find the video again.
Thanks, everyone.
Guys,
Bye.
have a great week.
Good night.